This is ionic compounds with polyatomic ion. Ionic compound with polyatomic ion. But before we continue, we have to understand what polyatomic ion is. Polyatomic ions are a group of atoms with a charge. Group of atoms with a charge. To make this more understandable, this is the way you see it in textbooks or anywhere they write it. But what it actually means is this. It means this is group of atoms and together they have this charge. Okay? This is group of atoms, together they have this charge. Group of atoms, and together they have this charge. That's what polyatomic ion means. Group of atoms with a charge. So, as I said, polyatomic ion is a group of atoms that has a charge, or a charged particle that consists of more than one atom. Okay? So, I want to show you a video that will enhance your learning on this. So
what's a polyatomic ion? Well, a polyatomic ion is a group of atoms that has a charge. Here's what I mean. You probably already know that individual atoms can have a charge. They can form ions. So we can get things like Na+, Mg2+, and O2-. Polyatomic ions are what happens when more than one atom comes together and they form a big group of atoms, and then that group of atoms itself has a charge. So polyatomic ions are things like NO3, 1-, where we have one nitrogen and 3 oxygens all connected together to form a group, and that whole group has a charge of 1-. Poly means many, so here polyatomic ions, we're talking about ions that are made up of many atoms, more than one atom. Let me show you a few examples of how this actually works. So here are two of my favorite polyatomic ions, ammonium and carbonate. Ammonium here is made up of 1 nitrogen connected to 4 hydrogens, and carbonate is 1 carbon connected to 3 oxygen atoms. Now, the atoms that are in each of these polyatomic ions, they have protons and electrons in them. So what we can do for both ammonium and carbonate is we can count up the number of protons that are in each of these atoms. If I do this for ammonium, I get 11 protons. And then if I count up the total number of electrons that are in this whole group, I get 10. So these two numbers don't balance out. I have more protons and electrons, which means that I have more positive charge. I have a net charge of 1+ because I have 1 more proton. So my net charge here is 1+, and I can write the formula for this polyatomic ion as NH4, because I have a nitrogen and 4 hydrogens, with a +1. I usually will also take the structure of this ammonium and put the whole thing in brackets and put a plus outside to indicate that this whole group of atoms together has a positive charge. I can also call this thing a cation, a polyatomic cation, because a cation is what we call ions that have a positive charge. Now, carbonate, we can do the same thing with it. We can count up the total number of protons that are in the atoms that make it up, and we can also count up the total number of electrons that are in this whole group. We get 30 protons total and 32 electrons total. So we have more electrons than protons, which means we have more negative charge. This is going to have a net negative charge, and since there are 2 more electrons, it's going to have a net charge of -2. I can write the formula for this polyatomic ion as CO3, 2-, 1 carbon, 3 oxygens, total net charge of 2-. And then I write my structure in brackets and put a 2- here to show that this whole thing has a net charge of 2-. We call this guy a cation because it has a positive charge, so we can call carbonate a polyatomic anion for negative ion. As I said before, there are a whole bunch of polyatomic ions. I have a small number of them on this list right here. A lot of times people ask me, they say, okay, if I knew that, say, nitrate was NO3, but I didn't know the charge. Would it be possible for me to figure out the charge just on my own? And unfortunately, no. It's very difficult to figure out how many electrons a polyatomic ion has, and so you need that to figure out the charge. Polyatomic ions are really important for when you're writing chemical formulas of compounds, and since you need to use them a lot, they're one of the things in chemistry that you really just have to memorize.
From what you've learned so far, can you identify the polyatomic ions here? Pause the video and identify the polyatomic ions. Hopefully you got it right. You got it right. Why are the other? You see, each of these has more than one atom, group of atoms with a charge. Let's look back. This is bromine. This is only one. And this is only one. It's not group of atoms. Cobalt, see, this is not oxygen, okay? This is C with little o. This is just an element, a cation, okay? So each of these is group of atoms with a charge. More examples of polyatomic ions are this, okay? So most times polyatomic ions ends in ATE or ITE. Most of them end in ITE or ATE, okay? Some of them end like this one, end in IDE, hydroxide, but most of them end in ITE. That is a very good clue that is polyatomic ion. So let's do example, writing formula, ionic compounds with polyatomic ion. The same concept. Calcium is not a transition metal. There's no Roman numeral. We write the cation of calcium. We look up phosphate. Sometimes it's required you memorize this. Phosphate. I try to do it this way so you don't forget. Okay. Then to show that group of atoms, you don't have to do it this way, but for those of you who are easily confused, I try to do it. Then we have the same crisscross. The charges are not equal. We make the charges equal by doing this. So we end up with this. Ca3. Now, 2. You see that? That's why I put this in parentheses in the beginning, so that you don't get confused. What does it mean? If we have this, it simply means there are 3 of this, and there are 2 of this. 6, 6. Okay, that's the formula. Now for silver chlorate, okay, silver is a transition metal, but it forms only one type of charge. Silver is only 1 plus. Then chlorate, you look it up as a beginner. You see, they are equal charges. You don't do any crisscross. Silver chlorate, that's it. You're done. So that's how to write the formula. Very, very easy. Okay. I still want you to watch this
To write
video.
the formula for compounds with polyatomic ions, we'll use the periodic table and a list of common polyatomic ions. We'll follow some simple rules here to guide us. So let's try one. We'll write the formula for potassium nitrate. For potassium nitrate, we know potassium is a metal, and then nitrate is a group of nonmetals, a polyatomic ion. And we know that because it ends in ATE. We go to the periodic table, and for potassium, the symbol is K. We can also look at the charge. It's in group 1, so its charge is +1. For the nitrate, we're not going to find that on the periodic table. We need to go to a common ion table and look that up. We go to our common ion table, and we can see that nitrate is NO3-. So we write NO3-, and now we just need to balance the charges. Potassium has a +1 charge, and then the nitrate, it has a -1 charge. Because the +1 and the -1 cancel out, that leaves us with KNO3 as the formula for potassium nitrate. So pause and give this one a try. Sodium phosphate. There's a link to the common ion table in the description of this video. For sodium phosphate, we have a metal and then our group of nonmetals. We know that it has ATE here. So we go to the periodic table, we look up sodium, we know that's Na, and it has a +1 charge. We look up the phosphate on the common ion table, and phosphate turns out to be PO4 3-. The 3-, that applies to this whole PO4. This thing stays together. We can think of it as one thing. So we have our 3- here, but a +1 here. They're not balanced. So to cancel out the -3, we'll need a +3. We can do that by changing the subscript. We'll put a 3 here. That means we have 3 sodium atoms. 3 times +1, that's +3, and that'll cancel out the -3, making Na3PO4 the formula for sodium phosphate. It's important to understand that when we have a compound with a polyatomic ion, like sodium phosphate here, that it's made up of those 3 sodium ions and then 1 phosphate ion. So the sodiums, we see they have a plus charge, and then the phosphate ion, that has that -3. Each of those oxygens with a single bond has a minus charge on it. The sodiums are attracted to the minus, and you see a structure like this here. If we put this in water, the sodiums, they'd dissolve, they'd move away, and we'd be left with that PO4 3-, that phosphate ion. The point is, the phosphate ion can be considered one thing. It's not going to break apart very easily. Let's try to do one that's a little different. Calcium phosphite. So pause and try to write the formula for calcium phosphite. For calcium phosphite, we have our metal, that's the calcium, and then the phosphite, that's our polyatomic ion, and we know that it ends in ITE. So when you see ITE, you're thinking polyatomic ion. We go to the periodic table. Calcium is Ca, and it has a +2 charge. The phosphite, we look it up on the common ion table. That's PO3 3-. Since we have an ionic compound, we need to balance the charges. But with the +2 and then the 3- here, that's a little bit challenging to kind of conceptually do. So we have a little trick called the crisscross method. We take the 3 here on the phosphite, and we move that down to the subscript for the calcium. Then we take this 2 and we move it over here down as a subscript for this phosphite ion. We do need to put parentheses around the phosphite to show that the 2 applies to this whole thing, not just the oxygen. We get rid of our charges, and that's the formula for calcium phosphite. We should check our work though. You remember calcium had a +2 charge, and the phosphite, that was a 3-. We have 3 calcium ions here, and each one's +2. So 3 times +2, it's a +6. And then we have 2 of these phosphite ions. So 2 times that -3, that gives us -6. +6, -6, those cancel out. So this is the correct formula for calcium phosphite. Give this one a try. Magnesium phosphate. For magnesium phosphate, we have Mg, and that has a charge of 2+. We look up the phosphate because we know 8 is a polyatomic ion, and that's PO4 3-. We start with the crisscross method, move the 3 down here, the 2 over here. We write our parentheses and clean up these charges, and that gives us the formula for magnesium phosphate. We do need to check our work though. Remember, magnesium was a +2, phosphate was a -3. 3 times +2, that's +6. 2 times the -3, -6. Charges cancel out, net charge is 0. This is the correct formula for magnesium phosphate. We'll clean it up a bit, and that's it. Let's try one more. This one's a little bit strange, so don't let it trick you. Pause and write the formula for ammonium carbonate. And I'll give you a hint. Ammonium is not on the periodic table. For ammonium carbonate, we have 2 polyatomic ions. So we look up ammonium on the common ion table, and that's NH4, and it has a positive charge. Carbonate, we know, is on the polyatomic table too because it ends in ATE and it's CO3 2-. We have this plus 1 charge here, and then we have the 2-. We know that we're going to need 2 NH4 ions to cancel out the -2 here. So if we put a 2 here, and then we need parentheses, that'll give us 2 times +1, so that +2 will cancel out this 2, and that makes this the formula for ammonium carbonate. To make your life a lot easier, I recommend, at the minimum, memorizing these polyatomic ions. That way you can quickly name and not spend a lot of time going back and forth to the list of polyatomic ions. For lots more practice naming and writing formulas, visit breslin.org.
Okay, do these practice questions. Do these practice questions and show your work as you saw in the examples I did for you. Show your work and make use of the chart, polyatomic ion chart. Pause the video. Hopefully, you got it right. Thanks for watching.